And yeah, and the reality is that, I mean, you know, you can go out and get a subnetting calculator app for free, and you will do that. But it's good to know how to do it. All right. All right, so what's up? All right, a network is divided into subnets. When the subnet mask takes some of the host portion of the IP address for the network address. This is what I was talking about before. And this is called classless subnet mask. It does not align the network ID with the network octets assigned with the class license. So, using the earlier example, the classless subnet mask for a Class A license of 69 that uses 2 octets for the network ID rather than the 1 octet assigned by the class would be 255.255.0.0. No reason you couldn't apply that subnet to that subnet, or that mask to that subnet. As you can see then, they've given you some other ideas of classless ones here. And if you total this up, what you're going to get is 255.240.0. Do you understand why?
Yes. 1 plus 30. Yes.
Right. Because that equals 240 based on our. And the other way to look at it is, if you're writing 240 again, I think they get to the site addressing. I don't know if we'll get there tonight or not. But what was it, 69? Yeah. If you wanted to do 240 and do cider, 16, 240, let's take 15 away. Right? So you can write addresses different ways. All right, so the applying concept section here, they give you a guy who is setting up a new network, creates TCP/IP settings. He uses a static IP address. He assigns a subnet mask of 255.255.240.0 and an IP address of 15.50.212.59 to this computer. So suppose this computer wants to communicate with a computer assigned an IP address of 15.50.235.80. Are they on the same subnet? Now, just looking at that before we go any further, you don't have to say any guesses, but just to yourself, what do you think? Yes or no? Are those on the same subnet? Let's first look at the binary values, so the first 2 octets, see if they match. Okay, so 212, right? 235. So to be on the same subnet, those first 4 bits have to match, right? Because we borrowed 4 bits from that, leaving 4 other bits of that octet. So if the first 4 bits don't match, they're not on the same network. If they do match, we're on the same network. Does that make sense? So 1, 2, 3, 4, 1, 2, 3, 4, 1101, 1110. Are they on the same subnet? No. Most of the computers are on different subnets. So one way you can always tell is, and again, just look at it from the point of view of, if you're doing 240, all you have to do is, it's 255, 240 is what you're wanting. So see how many you're borrowing here. Remember what I said about borrowing bits. Since we're classless, we're moving into the octet there. We don't have the full 255 here. We're borrowing bits from it, right? Okay. So if I'm adding up to 240, will I have something here? Yes, 128, right? That's going to fit. What's 128 and 64? That still work? Yeah. 192, right? And 32? Yeah. Where'd that come from? 2. What's that? 224? Yeah. Yes. So that works. 16 to 224? 240? Boom, there we are. So 240 is telling me I'm borrowing these first 4 bits. You can have these others, the hosts. Okay. Another way of looking at it is, of course, if it's the first 4, 8, 16, 20, right? Because we're just taking 4 of the 8 in there. So for CIDR addressing, it would just be a /20 if you wanted to look at it that way. You could just write out the IP address /20, and that would mean the same thing. That would be 255.255.4.0, right? Because you're just basically saying 21s, and then everything else is host. That make sense? I like CIDR addressing better, just because it's quicker to write out. But always, 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 if you don't know what it is, if you come up with this, and you're like, God, I can't remember what 20 is. Fine. Right? You know you need 32. So just start writing it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Right? And then start dotting that off. And that'll tell you what it is. Right? So, in that same vein, if I said /31 and you didn't know what that equaled, same deal. Just write out 31. You wouldn't do that, obviously. That would be the thing to do. 27, same deal. If you don't know what it means, just write out 27 ones, the rest 5 zeros, and there you go. Okay. All right. But in this circumstance, 240, as we said, what we're looking at here is they're taking the first 4. So these 2 are not in the same subnet. This gives you a brief explanation of the CIDR address. This is, I think, a very good one, but that's it. It's just the same thing. 1s followed by 0s. Now, guys, I don't know what this means exactly. I never have figured out this. Short stick represents a subnet mask for a network of sticks.
I was looking at it back because I've been looking at it for a while. Like, how does this make sense?
I'm a pretty smart guy. I'll be darned if I can figure that picture out. I guess 1, 2, 3, 4, 5, 6, 7, 8. Right? So the subnet mask that they're giving us here is 255.255. Is that what we're supposed to take from this? That is the single most unhelpful. And there's no explanation anywhere. Like there's no teacher explanation either. When I'm looking at it, there's not anything like sometimes, you know, they put like idiot notes for the teachers in there because like, hey, we have to teach this stuff. So that's what this means. There's nothing. So it probably makes perfect sense. It's just too dense to get it. But, yeah. So anyway, we'll move on.
It's made by engineers.
Right. Public, private, automatic, private IP addresses. So when a company applied for a Class A, B, or C license, it was assigned a group of IP addresses that are different from all other IP addresses and are available for use on the internet. The IP addresses available to the internet are called public IP addresses. Subnets are private IP addresses. Okay? A company conserves its public IP addresses by using private IP addresses that are not allowed on the internet. Within the company network, computers communicate with one another using these private IP addresses. A company using a private IP address on a private network can still access the internet if a router or other device that stands between the network and the internet is using network address translation. NAT is a TCP/IP protocol that substitutes the private or the public IP address of the router for the private IP address of the other computer, and these computers need to communicate. So remember before we were talking about, okay, well, what happens when it gets inside the company? The specific protocol that actually translates that for you. It says, oh, okay, you're coming in here and you want to talk, well, on this network, this is John 1, John 2, John 3. So the specific protocol that does that is network address translation.
That probably would have helped a lot more when you were explaining it earlier to me.
You're welcome. Because of that, a small company can rely solely on private IP addresses for its internal network and use only one public IP address assigned to it by its ISP for internet communications. IEEE recommends that the following IP addresses are used for private networks: 10.0.0.0 through 10.555, etc. 172.1.6 through 172.3.1, 192.168 through 192.168.255. If a computer first connects to the network and is unable to lease an IP address from the DHCP server, it uses an automatic private IP address in the range of 169.254.something XY. So does all that make sense? Clear as mud? All right. What questions do you have? We are going to stop for tonight because I don't want to try to tackle any more of IPv6 after all that.
IPv6 uses hexadecimal, right?
It does.
Yeah,
So rather than base 2, IPv6 uses a base 16 system.
Oh boy.
No. I'm telling you, once you use it, and when you get on into networking and really start, you're going to wonder why we're not already using IPv6. It's so much easier. It makes so much more sense. But it can't get here fast enough. It'll make your lives much easier, I promise. All right. So, and really what I covered on the exams, you will be asked on the final if two networks are in the same subnet, right? So and it'll probably give you an example exactly like that. So remember, all you got to know is how many bits am I borrowing, right? If I'm borrowing 4 bits, then to see if that binary it out, and if those first 4 bits are not the same, not exactly identical, then they're not in the same subnet. Okay. But you will be asked that question.
It's going to tell us how many bits it borrowed, right?
Yes. But it'll give you the subnet mask, and that tells you how many bits are borrowed.
Right.
So
I wish they would use the the slash notation?
You wish they would or wouldn't?
Would.
Oh, well, you can work that out.
Yeah.
Yeah, just again, binary it out and just change it over. If it helps you to look at it in Cider, you just binary it out, change it over to Cider. Once you've used it enough, then you're pretty well good. Actually, I do have a cheat sheet that I can put up.
Please do.
You know what I'll do is I will send a copy to you guys. I will email a copy to you guys. And if you're going to memorize something for networking, memorize this because it's very simple to memorize. It's not something that you've got to like commit 50 numbers to memory. You just have to memorize how to write things out. And when you take an exam, most of the time, you're going to be able to have a scratch piece of paper. Make that the first thing you write out on the scratch piece of paper. And then what it will do is show you an immediate back and forth between Cider notation and your subnet mask and what your host is and how to do that. By the way, one thing I didn't show, which I should go into for you. Just very quickly. If you ever want to work out, based on a subnet mask, what your new subnetwork address is going to be, you can always use your binary to do that. You can do a little addition or subtraction type thing, sort of. Let's do something easy. Let's do a 128. So 5, 6, 7, 8 dot 64. This is 1, 2, 5, 6, 7, 8 dot
33.
0, 0, 1, 4, 5, 6, 7, 8. Smart pants. Dot 0. 1, 2, 3, 4, 5, 6, 7, 8. Run out of space because of the screen. Okay, so what do we want our subnet mask to be? 255.255. 240, since we just used that. Okay, so what am I doing?
So the 8 ones, 8 ones, 4 ones. And
So
then the rest
21?
is- Yeah, 20.
1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, very simplistic example here. Okay, but for your address, for your new network address, and it's going to, on this example, it's going to look just like the old one because we came up with an easy number. But essentially, all you have to do now, everywhere you have ones coinciding, you bring down a 1. Everywhere you have zeros and ones together, you put a 0. Everywhere you have 2 zeros, it's a 0. Okay? So 1, 2, 4, 5, 6, 7, 8, dot, 0, 1, 2, 4, 5, 6, 7, 8, dot. 5, 6, 7, 8, dot, 0, 0, 7, 7, 7. So in this particular example, it didn't change our network address, just because, well, it did something. We got rid of this, right? So we went to 128.64.0, which would be our new address. That would be our subnetted address. That's where we would start at, right? So internally, in your company, you would have 128.64. Whatever else we can. We had 0, 0 in the first place, but if we had 0, 1 or whatever, you would start at 0 for your subnet address, and then you could work through there. Right? All right. So I guess that's it. Any other questions? All right. See you Thursday for IPv6.